morning, students. So today we have to start with the structure of glucose. And yesterday we have understood that what is glucose and what will be the chemical formula for this glucose. So that is C6H12O6. So yesterday we have understood that there is CHO group, one functional group CHO group, and along with this there will be 5 hydroxy group. Got it? So that is the okay, but I just want to say that glucose. I want to say that glucose is always represented as D, capital D plus glucose. It's not minus. It's D plus glucose. Got it? And instead of this capital D, we are not supposed to write this small d. What did you get? This D is for. Is it dextro? Is it for dextro? No, it's not for dextro. Actually, here the D structure resembles the structure of glucose resembles with glyceraldehyde. Got it? This doesn't mean dextro. It doesn't mean dextro. Okay. What does it is like? What does it explain? It explains the resemblance of the structure with the glyceraldehyde, not dextro. Got it? The small d, if we are writing, that is called dextro. So what this plus sign? This plus sign actually represents its representation. This capital D is not representing its rotation. This plus sign, and plus sign, whenever it is plus sign, we say that it is dextro. Yes, right side, towards the right. So that's why whenever we like a structure, we write this is dextro. That means its structure resembles with the glyceraldehyde, and here the plus sign shows that it is dextro rotatory. Got it? So glucose is always dextro rotatory plus. Got it? So if we see the structure of glyceraldehyde, the glyceraldehyde structure is like this. The upper one, the first have it is CHO, and at last bottom CH2OH and then HOH. So if you see that the structure of in between only that four COH group are there, isn't it? Like this. But as a whole, if we see the outer structure, so we can say that glucose is also having at the top CHO and at the bottom CH2OH, and on the left side, right side we have OH, and on the left side H. So it's similar as glyceraldehyde. Got it? So this is plus glyceraldehyde and this is minus glyceraldehyde. It means that it is dextroglyceraldehyde and it is levoglyceraldehyde. So all the glucose jo hote hain, they are plus glyceraldehyde. Got it? It like this. So dextro D for glyceraldehyde resemblance with glyceraldehyde, and plus sign means dextrorotatory. Got it? Okay. So here is this glucose structure. We can see that this is CHO group, isn't it, at the top, and here also CHO group at the top, and at the bottom CH2OH group is there, and here also at the bottom CH2OH group is there, isn't it? So it is like that. In between COH group, in between COH group are there. So like resemblance. Okay. So like this. Okay. Now cyclic structure of glucose. What's the need to explain this cyclic structure? Actually, glyceraldehyde. If we have glucose, we have learned about this in aldehyde chapter. Then if there is CHO group, this shows so many reactions. Have you heard that? Can you recall that? The cyanohydrin reaction, then semicarbazide, then hydroxylamine, 2,4-DNP, Sif's test. बहुत सारे reactions थे, if you can remember all this. So out of that, we see, whenever we see that this CHO group, although the glucose is having CHO group, but it doesn't show 2,4-DNP test, Sif's test, and doesn't give the addition product with NaHSO3. What does it mean? This is also another set of important question. It says that write the reaction which shows that glucose is having cyclic structure, or write the reaction which cannot be explained by the open structure of glucose. So like this question will be asked. Okay. So you have to write for this that although the CHO group is present over there, but it doesn't give 2,4-DNP test, Sif's test, and addition reaction with NaSO3. These are the three reactions which is not given by the open structure of glucose. So then that research were there, and then the scientists have discovered this, that glucose is actually glucose exists as a cyclic structure. And how it makes the cycle? So let's see how it makes the cycle. So in this, this is CO double bond OH is there, isn't it? What will happen? This bond is going to split on this side, due to which it will have O minus, isn't it? O minus, and here it will have plus charge. Got it? So what will happen? This fifth carbon, it's not in between anyone. It's fifth carbon. Fifth carbon, the H will go on. This H plus being better leaving group will go along with this oxygen, and it will complete with OH. Got it? Clear? And then this O will have negative charge. This O will have negative charge, isn't it? And this carbon is having plus charge. So there will be a bond between like this, CO. So this bond can be like this. You can see this C, this is the C, yes. And here it is the bond like O, which is also linked with the carbon, fifth carbon, isn't it? Like this. Or you can, or it can make like this. Yes. So what is the difference between these two? See, in this structure, how we learn? We learn that first carbon, OH group, is in the ring, inside the ring, okay? And here outside the ring. Got it? And okay, one important thing about the glucose structure I forgot to say, that all the OH in between the carbon, there are 4 carbons which is having OH group. So in that, all the hydroxy group will be on the right side except the third carbon. The OH group on the third carbon will be on the on the left side. Got it? And rest all the OH will be on the right side. Third carbon, it will be on the left side, and on all rest carbon, it will be on the right side. I hope it is clear. Okay, so this point is important. ये याद रखना है that in the glucose structure, all the OH group is on the right side except the third one, where that OH group is on the left side. Okay, so listen, this can convert into two way. That if this OH, I'm making the ring over like this acid, so this OH will come inside the ring, this like this. OH is coming inside the ring and OH is coming outside the ring. So if it is inside, under, okay, then it is alpha. So just for learning, we can say that under alpha. Okay, got it? And this is for always. D, it should not be here minus sign. It is not minus. It is just simply written like thoda separation deke likha hua hai. So it is glucose. Jab bhi, whenever we talk about the glucose, it will be D plus glucose. Okay. Now we have two things. One is alpha glucose, another is beta glucose. If it is bahar, B for bahar and B for beta, you can say that. Okay. So like this you can learn. If it is inside, OH group is inside, it is alpha, and if it is outside, it will be beta. But there is no change in D plus glucose. Why? Because D shows the resemblance of the structure with the glyceraldehyde, and plus shows dextrorotatory nature. So is it clear? Got it? And two important things I have told you in this slide, that these 3 reactions, 2,4-DNP test, SIF test, and addition product with NaHSO3 cannot be given by open structure of glucose. Okay, first. And second thing I have told you this, that on the glucose, OH group all the OH group is on the right side except the third carbon OH. Okay, and one more thing, third thing I have told, if OH group on the first carbon is inside the ring, it will be alpha, and if OH group on the first carbon is outside the ring, it will be beta. Got it? So these are the 3 important points for this slide you should learn. Now, next thing. The pentaacetate of glucose does not react with NH2. These are the additional reaction which cannot be given by the open structure of glucose. So if it is asked, write the 3 equation. Better you write that SIF test, 2,4-DNP test, and addition reaction with the Na2SO3. Done. But rest other reactions are also there. like it's the pentacetate of glucose does not react with NH2OH. Jabki we know that aldehyde group, if it is there, so it will react with NH2OH. Okay, which shows that absence of CHO group. That means there is no CHO group. Why it is no? Like let me show you. Although you can see CHO group, but it exists as a cyclic form, so you cannot see the CHO group. Can you see the CHO group? Is there? No. So although it is having CHO group, but the CHO group is not free. Got it? So that is the reason for this, that it doesn't give the reaction with NH2OH. So it shows that absence of CHO group. That means CHO group is bonded. And when it will be bonded? When it exists as a cyclic structure. Got it? So above reaction cannot be shown by the open structure of glucose, and due to which it was proposed it must have cyclic structure. Got it? Experimentally, it was found that glucose forms 6-membered ring in which OH at C5 is involved in the ring formation. That I have told you, I have explained. It will have 6-membered ring, okay, and which in which OH at C5 is involved in ring formation. Let me show you again. This one, if it is going to be form or like it is a cycle, if you consider. So see 1, 2, 3, 4, 5, and the 6th member. So this is the cycle, isn't it? The 6-membered ring. But we will explain it in another way. How to represent that is different thing. So here also it is there. How it is the same thing explained over here. Got it? So how it will form the 6-membered ring, that I have shown. And the another thing also that OH of the C5 is involved in the ring formation. Got it? Okay. So next thing, since the 6-membered ring of glucose resemble with pyran, this is bio student must be knowing this, that 6-membered ring is pyran. It resembles with a pyran. That's why it is known as pyranose. Nose for, O's for carbohydrate. Being carbohydrate, we have used pyranose. Got it? So since the 6-membered ring of glucose resemble with the pyran, that's why it is known as pyranose structure. And alpha, when it is called alpha, right now I have explained, if OH group is inside, OH group at C1 is inside the ring, and if OH group is OH group at C1 is outside the ring, it is beta. And another thing, important thing, alpha and beta structure are anomer of each other. Sometimes it is asked that what do you mean by anomers? So anomers, it is important point you can write. It is important point you can write as a key point to learn that anomers definition. How to define that alpha beta form of the glucose is known as anomer. And what is that basic differences? That if the OH position at C1 is different, then this type of compound are known as anomer. Got it? So how to make this? Let me show you with another slide. Like this is. So we have done this one. And one more thing I just want to tell you. This structure is called Haworth structure. Okay. This is called Haworth. H-A Haworth reaction. Haworth structure. Got it? Haworth was the scientist, and it was given by him. So that's why in honor of him, it is said as structure. Like Haworth structure. Okay. So how to make this? Let me explain. This we know that, and from this structure only we will get the Haworth structure. How? So see, as I told you that it is pyran. Okay. So what I will do, I will like horizontally I will keep it. So this is oxygen, and then here oxygen I have kept over like this, and then it is going to attach with the first carbon. This is C. So in this downside we will start. Okay, it's not on this side, it will be downside. So it is carbon number 1, and then carbon number 2, carbon 3, 4, 5, and 5th carbon, this is CH2OH is there. So that's why. So how to how you will keep this HOH upside downside, it matters. Okay, so let me explain you. As I told you that if it is inside, if it is under, it is alpha, and if it is inside alpha, then it will be downside niche. Alpha under niche. Got it? Like this you have to understand. So if it is inside the ring, that means it is alpha, and this OH, if it is inside, then it will be downside. We have to draw the structure downside. So let me see that H is there. So H will be upside and OH will be downside for the carbon 1, isn't it? Similarly, OH is inside the ring, so that will be again downside. Here, OH is outside the ring, so that's why OH will be upside. Got it? Or you can say that H is inside, so that H will be downside. Okay. Similarly, in this, OH is inside, so OH will be downside. And for this, it is always CH2OH will be on the upper side and H will be inside, downside. Got it? So this is the structure. How about the structure? How to draw? Like now, this one, try to understand this. OH, and here O, and this carbon 1. So let me carbon 1 over here, carbon 2, 3, 4, 5. So check in this. On the first carbon, the OH is outside. So that's why it will be upside. Outside, upside. Got it? Or you can say that the H is inside the ring. So that's why H will be downside. OH is inside the ring. So OH will be downside. Here H is inside the ring. H will be downside. Here OH is out inside the ring. OH will be downside. Got it? And in this case, so it is always H will be downside. I hope it is clear. This is a Haworth structure and I hope it is clear. So if there is any doubt, you can ask. Okay. So now let me start with this next slide. Next slide, and this is this. When we draw in this open structure, this is called Fischer projection. Okay. This open structure is also known as Fischer projection. So sometime it can be asked that what will be the rotation in the Fischer projection of glucose, alpha D glucose or beta D glucose, something like that. So you have to understand that Fischer projection is open structure, okay, and the ring structure is called Haworth structure. Got it? So this is the way it is, how it is making like that. We can see this H here, this bond is going to move on this side. It is different way actually. This bond is going to break on this side, so here it will be O minus. So this H will come with this OH, okay, and this oxygen will be left over there, so it will make the bond. So ये यहाँ पे दिखा रहा है that how this H is removing like this. ये H जो है, this is going out in form of this, and this moving. So this H is coming over here. Is this clear? Any problem in this? This is the lone pair. Here it will be negative charge and here it will be positive charge. So this will be the bond forming. I hope it is clear. Yes. Okay. So this is a cyclic monosaccharide, or you can say that the Haworth structure of. Now tell me whether it is alpha or beta. See, first carbon OH you have to check. It is downside, so it is alpha carbon. Hope it is clear. Yes. Now the next is fructose. Fructose has also same formula, C6H12O6. But what is the basic difference? Can you tell me? Yes, this is ketone functional group. It is having ketone functional group, but in glucose there was the aldehyde as a functional group. Fructose can be obtained by hydrolysis of sucrose. We have learned on the first phase, that sucrose on hydrolysis gives 1 mole of glucose and 1 mole of fructose. So this will be obtained by the hydrolysis of sucrose. Okay, this is the equation. Glucose and fructose, we want this. What is glucose and fructose are functional isomer of each other. In this, aldehyde is a functional group. In this, ketone is a functional group. Got it? And that's why it is also known as ketohexose. Hexose means 6 carbon, O's means carbohydrate, and keto means there is ketone as a functional group. What will be the structure? Experimentally, it is observed that ketone group is present at second position. Because obviously, ketone group cannot be present at the first position. We know that because it is a secondary functional group, isn't it? So it is also, that is a thing. First, ketone is present at the second position. Okay. And second, it is also D. ये भी D ही है. That means its structure is also resembled with the D, but not dextro. It is levorotatory. So whenever we have to write fructose, it will be D minus fructose. Got it? D for glyceraldehyde, minus for levorotatory, and fructose we know. So like this is the structure, D minus fructose. Just confuse mat ho jana. This is just a hyphen, okay? It is nothing. It is D for glyceraldehyde, resemblance with the glyceraldehyde, and this negative, that means it is levorotatory, and fructose, why? Because this ketone group is there. Okay, so now the next thing, how about the structure? If you'll make for this, it will give you the 5-membered ring. How come? See, the same way. This one bond will shift over here. It will have negative charge. The 5th carbon, this OH, being better leaving group, will come to this point, will attach, and what will happen? This C will make a linkage with this oxygen, isn't it? Here it will have plus sign. Sorry, here it will have minus sign, and here it will have there is this bond is going to shift over here. Okay, plus sign. So this is the plus and this is the minus, oxygen minus. They will form linkage over there. Got it? So how? In the next slide I will explain like this. See, in this structure it is, if you see in this case, the first carbon CH2OH will be there. In the first carbon there will be first carbon CH2OH will be there. Got it? So this, if we will check the ring, this is 1, 2, 3, 4, and this is the oxygen in the ring, isn't it? That will be in the ring. So it will form the 5-membered ring, and that is resemble with furan. So that's why it is known as furanose. I hope it is clear. Okay, so I wanted to explain like this. Ab yahan dekho, what will happen, as I told you, that this C will have plus charge and this oxygen will have the linkage. Again the same way, but here it will be what, in that glucose we were doing that OH on the first carbon, but here we will check OH on the second carbon, because I have explained now that ketone group is on the second carbon, isn't it? So if second carbon OH is inside the ring, it will be alpha, and if second carbon OH is outside the ring, it will be beta. Rest is same, D minus, and fructofuranose bhi kaha ja sakta hai ise. Fructose, because you know that its name is fructose and its a structure resemble with the furan, so that's why it is also known as furan. And O's for carbohydrate, so it can also be called fructofuranose, or you can say that fructose. Similarly, that glucose one can be said as D plus glucopyranose or glucose. Yes. However, the structure, if we'll draw, this CH2OH is this on the second carbon, it is on the ring, it is in the ring. So second carbon, and then oxygen is attached with the second carbon. So oxygen is attached with the second carbon. Don't forget about it. Marking is very important. Second carbon, third, fourth, fifth. अच्छा, whenever we draw the structure in general, जब भी हम hover the structure draw करते हैं, this numbering we go in the right side. It's never like here we cannot write two. We don't write two. It's a conventional, you can say, always through the right side we go. So second carbon, third carbon, fourth and fifth. So on the second carbon, check this, OH is inside the ring, so it will be downside, isn't it? On third carbon, H is inside, so H will be downside. On fourth carbon, OH is inside, so it will be here like this. Yes, and this is the for both glucose and for fructose, it is same. CH2OH group will be upside and H will be downside. Similarly, if I'm talking about beta, see, in this CH2OH is inside, so that's why CH2OH is inside, isn't it? Again, H is inside, so H is inside, OH is inside, so OH is downside over here, and this CH2 will be always upside. So I hope it is clear. Yes, there is no problem at all. Now, this is the disaccharides. So if we have to what does it mean, disaccharides? That means they are going to the two monosaccharides, that means two what we say, the monomers are going to combine with each other to form a bigger molecule, and that is called disaccharides. Or we can say that disaccharides are such a carbohydrate which on hydrolysis gives 2 unit of 2 unit of carbohydrate. Got it? So we have done sucrose, like maltose, like lactose. So they are the disaccharides because on hydrolysis they produces 2 molecules of carbohydrate, a simple carbohydrate. Got it? In the disaccharides, 2 monosaccharides, either same or different, are joined together by an oxide linkage. This is important, an oxide linkage, along with the loss of H2O. So that means obviously disaccharide can be considered as the condensation polymers of two monosaccharides, isn't it? Because H2O is coming out and there will be oxide linkage. These disaccharides, in this disaccharides, the monosaccharides can be same or different. Okay, how? Let me explain it. This is important definition you have to learn here. It is so many times it is asked, what do you mean by glycosidic linkage? So glycosidic linkage is, you are supposed to say, not say simply linkage, you should say the oxide linkage. This is the most appropriate way. So the oxide linkage between two monosaccharide is known as glycosidic linkage. Got it? Start with the sucrose. The molecular formula is C12H22O11, and if there is an important question asked from this, that is why this is called invert sugar. Sucrose is called invert sugar. Why? It is again the important point. Okay, and so many times it is asked. So you should know that sucrose, when that experimentally it is checked, we got that this is dextrorotatory. Got it? But on hydrolysis, it gives glucose and fructose. We know that we have done the very first day, and glucose is always dextrorotatory. Right now only I have explained, and fructose is always levorotatory. So it gives dextroglucose and levofructose. But when it is if you check that levo-rotation is 92.4, that means much greater than the dextro-rotation, that which is 52.5. So net resultant as a whole, the mixture becomes levo-rotatory. And since the rotation becomes reverse, so that this product is known as invert sugar. This is very important thing. Got it? Important definition. Now we will understand that how this forms the glycosidic linkage. So mark it as a very important question. Got it? Now we will understand the glycosidic linkage in this. So for this, you should learn that there is a glycosidic linkage at C1 of glucose, and that glucose will be alpha glucose, and C2 of beta fructose. Got it? This is with respect to, if we talk about that board exam, it is not so important. It is never asked. But yes, this can be asked in all that entrance competitive exams. Okay. So let's do the structure. So if we draw the structure of this is alpha D glucose. The first carbon, which is inside, that's why it is downside alpha, isn't it? And beta fructose. That means the OH group will be upside, like this. So what will happen? This will H of this and OH of this will come out as water form, to form water. So what will happen? This oxygen is left over there, and here it is bond. So this, there will be linkage with this. Got it? So this is the linkage. So this is also called 1,2 glycosidic linkage. It is also known as 1,2 glycosidic linkage. Sucrose, in sucrose there is a 1,2 glycosidic linkage. Got it? And this is the oxide linkage, you can say. So here it is sucrose. I hope it is clear. Yes. OH, this is alpha D glucose, this is beta D fructose. How I said this is alpha, and glucose, how is it? See, this is the pyrene structure which resemble with the glucose, and this is the furan, 5-membered ring. So fructose. Why it is alpha? Because OH group, first carbon OH group is inside, and that's why in Haworth structure it is downside, isn't it? And it is beta. Why? Because in Haworth beta is bahar, that means outside, and in Haworth structure it is upside. So that's why it is beta. I think you got it. Okay, so H from this and OH from this will come out as a water, condensation polymer will be there, and this O will be there, and this is called oxide linkage, or it is also known as 1,2 linkage or 1,2 glycosidic linkage. Important hai, you should know this thing, this point you should know. Okay, let me make it star. Okay. So one more important things for sucrose, you can understand. This sucrose is known as table sugar. That table sugar we always use in our house home. Consists of one glucose molecule and one fructose molecule, because it is a disaccharide, so not more than one glucose and one fructose, and linked by alpha beta or 1,2 glycosidic linkage. Sucrose is the most abundant disaccharide and is commercially produced from sugarcane and sugar beets. Sugarcane, आपको पता ही है. So, because of this glycosidic bond in sucrose involves both anomeric carbon, neither monosaccharide can undergo mutarotation, and so sucrose is not a reducing sugar. What is this mutarotation? It is not muta, it is muto, it is muta. Okay, I will tell you, I will explain that what is this mutarotation. So, neither alpha nor neither glucose nor beta fructose undergoes mutarotation, and hence it is a non-reducing sugar. So I will explain about the mutarotation in next slide. So, and that's it for today, and this is the structure I have explained already. About the mutarotation we will do in the detail, so just wait for that moment. By the time, this is the important thing about the sucrose. It is also known as table sugar, and 1-2 glycosidic linkage is there. 2-3 important points are there, just you should mark it. First it is table sugar, another it is glycosidic linkage it is having. Next it is the combination of glucose and fructose, and sucrose is a non-reducing sugar, or not a reducing sugar, or non-reducing sugar we can say. Got it? So that's it for today. Next class we will we will study another disaccharides like maltose and lactose, and we will know about this mutarotation also. So till then, thank you class.